Yes, class. So, am I audible to all of you? Faiza, Humam, Austin,
Yes, ma'am.
Madiha.
Yes, ma'am.
All right. So, yesterday we had started with magnetic Lorentz force. So, what was magnetic Lorentz force? If a charged particle is moving with the charge q with a certain velocity v in magnetic field, the magnetic force is given by the formula q into v cross b. This is the formula that we use for magnetic Lorentz force. So we were discussing 3 cases. 4 cases are there. We were on the third case. 2 cases we had already discussed. First case was if the angle is 0 degree, that is the charge is moving parallel to magnetic field, then of course sine 0 degree, the entire force will become 0. Similarly, if the charge is moving anti-parallel, that is 180 degree, then also it will become 0. A special third case we were discussing when the circle is actually formed. This we were discussing that if the particle is perpendicular to magnetic field, see, when it is moving perpendicular to magnetic field is inverse, velocity is like this. So this is the case third, which is that magnetic field is perpendicular. Now see, if magnetic field is perpendicular, we could notice that entire charge is moving in the form of circle. If it moves in the form of circle, force is directed towards the center. And one of you had answered yesterday that the force which is directed towards the center is which force? Centripetal force. Very good, Faiza. The force is centripetal force. So, does anyone remember the formula of centripetal force? In class 11th, you must have done formula of centripetal force. So, formula of centripetal force. mv square by r. Very good, Faiza. mv square by r. That's exactly what we are going to use here. All right, a little just recap of the circular motion which you have done in your class 11, uniform circular motion. So in circular motion, when the force is directed towards the center and along the radius, this is what we call as the centripetal force, whose direction is given by along the radius towards the center. This is the exact direction for centripetal acceleration also. Centripetal acceleration is given through centripetal force only. Now, the way Faiza has answered it correctly, centripetal force is mv square by r, or if you want to write it in terms of omega, see, omega is equal to VR. So this becomes m omega square r, where m is what? M is the mass of the particle. Mass of the particle. Now, yes, this was one formula. From why have I written like this? Because omega is equal to V by R. So V is equal to omega R. So from this, when you substitute in here, you get this formula. So this is from your class 11th. By now, all of you should remember this part at least. All right. Now coming to your class 12 portion. You have Q V cross B as the force. This is your magnetic force, right? And we know that we are taking third case. In third case, theta is 90 degree. Particle is perpendicular. So force becomes QVB. Right, sine 90 degrees is 1. So we'll write QVB. Now centripetal force is mv square by r. So see class, centripetal force, no. Centripetal force is actually not a force. Centripetal force is a requirement that is fulfilled by different forces. Means centripetal force is not a true force in itself. You have different forces in nature which fulfill the function of centripetal force. For example, if in space we are talking about, a planet is moving. So that planet is actually providing the necessary centripetal force for the particle that is moving. Now, the necessary centripetal force is provided by the gravitational force, right? If I say an electric charge is moving, in a circle. So whatever is the centripetal force, means whatever force is required at the center, towards the center, this is fulfilled by the electrostatic Coulombic force. Similarly here, if the charged particle is perpendicular to magnetic field and moving in the form of circle, so whatever is the force now directed towards the center along the radius, that is provided by the necessary magnetic Lorentz force, magnetic force over here. So centripetal force is not actually a force. It's a requirement that is fulfilled by different forces. So the necessary centripetal force over here is fulfilled by the magnetic field. So it means we can equate both these forces, centripetal forces provided by magnetic field. So QVB is equal to mv square by r. From here, v square, v get cancelled. Formula of velocity will become QBR divided by M. QBR divided by M. And what is the formula of radius? MV divided by QB. This you have to remember. The radius of circular path. The radius of circular path. So this is the formula of radius. Formula of time period. See, formula of time period, it is not difficult to find out. Why? Because time period is basically distance covered by the speed. Speed is distance by time. So time will be distance by speed. Now in circular motion, what is the distance? The periphery of the circle. And what is the periphery of a circle? Circumference, that is 2 pi r by velocity. We have just calculated the formula of velocity, QBR by M. So we can put in the formula 2 pi r QRB by M. So RR get cancelled. So we are left with T is equal to 2 pi M divided by Q. This is the formula of time period, 2 pi M divided by Q. All right. Acha, one more thing. What is the relation between frequency and time period? Can anyone answer? Frequency and time period. Yes, frequency and time period, a very common formula it is. 1 by frequency. Very good, Faiza. Time period is actually 1 by frequency. So see, if we know the formula of time period, frequency is 1 by time period. So frequency will be just the reciprocal of it. That is QB divided by 2 pi M. This is the formula of frequency. Fine, this is the formula of frequency. One more thing. Omega was what? It was velocity divided by the radius, and velocity is QBR divided by M. And this R. So RR get cancelled. Omega becomes QB by M. One more formula you can use. Omega is actually 2 pi, frequency is omega. So you can multiply this term with 2 pi. 2 pi will get cancelled. Again, you will get QB by M. Last formula which you have to remember, that is the formula of kinetic energy. So see, if you have the velocities formula with you, we have the velocities formula. We know how to calculate kinetic energy. Kinetic energy is half mv square. All these can come in your exam. This is a part of your syllabus, especially time period and radius. These are extra, which might come in the exam, but time period and radius, they are very important. They usually come in the exam. So what was velocity? QRB divided by M. So kinetic energy would become half mv square. So Q square, R square, B square by M square. So M and this square get cancelled. So final kinetic energy becomes Q square, B square, R square divided by 2M. This is the formula of kinetic energy. One question that comes is, If the speed of the particle is increased, how will the time period change? So remember, time period, this is independent of both radius and velocity. You can see radius and velocity, they were there initially, but after substitution, it just depends upon the mass and magnetic field. This is a very, very common question, especially students who have to appear for NEET. In NEET, this question has repeated so many times, where all the four options are given regarding time and kinetic energy. Kinetic energy is also independent of velocity. It depends on the radius. So you, by looking at this formula, you have to check which quantity depends on which quantity. Radius and time period, this and especially this, they both come a lot to derive in your subjective exams also. Noted down, one type of question that comes is different values will be given for different particles, and you have to find out ratios of time period, radius, velocity, momentum, kinetic energy, different quantities. That we'll see later on, but first note down it from here. Any doubts if you have, you can ask. Till here, all of you have understood how to derive the formula? Yes? Austin?
Yes.
Homam?
Yes, ma'am.
Shavis, from here only it started, from uniform circular motion. Before that, no, this we had already done in the last class. So from revision of uniform circular motion, we had started this. See class, this question, a proton, deuteron and an alpha particle enters in a uniform magnetic field. See, we have to find out ratios of two quantities. Firstly, if the velocity is same, if the momentum is same, kinetic energy is same, potential difference is same, these are the things. But see, what is the actual relation between all these that you have to remember, not only for this question, for the rest of the questions also. See, mass of proton is, let's say, mp. We have to find out the relation between all of these quantities. So if mass of proton is mp, then mass of alpha particle is double of mp. Not alpha particle, deuteron. Mass of deuteron is double of mass of proton. And mass of alpha particle is 4 times the mass of proton. This you have to remember. All right. Regarding the charges. Charge on the proton is the electronic charge, 1.6 into 10 to the power minus 19. Charge on deuteron is also this only, electronic charge. But the charge on alpha particle is double of it, 2 times the electronic charge. Fine. So mass of particles, you have the relations between the charges. Now we can find out the ratio of radii. You have to find out the ratio of radii if they have the same velocity. So what is the formula of radii? Radii formula, the formula of radius is mv by qb. So mass, charge, magnetic field will be same for all the quantities. Why will the magnetic field be same? Because both the charges are kept in the same magnetic field, right? Velocity, this you have to find out. See, ratio of proton is to ratio of deuteron is to ratio of alpha particle. Mass of proton, velocity of proton, charge of proton, magnetic field is same. Mass of deuteron, velocity of deuteron, charge of deuteron, and magnetic field is same. So I'm not writing it as BD or BP. Mass of alpha particle, velocity of alpha particle by charge on alpha particle and magnetic field. See, magnetic field will be cancelled from here. Now ratios. Mass of mass of proton, let's write it as MP only. Fine. If they have the same velocity, then no need to write VP, VD, V, alpha. They will also be the same, right? If velocity is also same, let me write it here only. Velocity is given same in the question, so velocity will also be same. This will also get cancelled. Now mass of proton and charge is E. Mass of deuteron is double of mass of proton and charge is E. Mass of alpha particle is 4 times the mass of proton and charge is 2E. So MP, 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 E, E, E get cancelled over here. And from here we have 2. So what is the ratio? 1:2 is to 2. First tell me. This part is clear. If the first part is clear, you all will be able to solve the rest of the parts. Clear? Should I repeat it? Humam, Shavez, Rabia, Rabah. Clear, no? Okay, Faiza, I'll repeat. See, this is the formula MV by QB given to you. You have to find out the ratio. So whenever we have to find out the ratios, what do? We take the quantities which are similar, we cancel them out. So here what is happening? When you have taken their ratios, masses and charges are different. So we have taken them and reduced them to the same unit. Mass of proton is known to us. So mass of proton, we have converted mass of deuteron also into mass of proton, mass of alpha particle also into mass of proton, and charges also. That's what I was telling you in the initial portion of this question. This is the relation between their masses and charges. This you should remember for all the questions. If velocity and magnetic field are same, velocity and magnetic field will get cancelled. And what about their masses and charges? They can be cancelled. So we are left with just 1:2:2. Now clear, Faiza? All right. See, now this you all try if it is same momentum given. Same momentum is given. It means what is the formula of momentum? Formula of momentum is mv. So it means mass into velocity this time is same. See, in the previous question, nothing was mentioned regarding the masses. So we had to take the masses also, mp, 2 mp, 4 mp, so that it becomes a single unit. This time masses are also same. So it's an easier question than the previous one. This is much more easier than the previous one. See, rp is to r neutron is to radius of alpha particle. This is equal to, see what is the formula of radius? Mass into velocity by charge into magnetic field. So mass, velocity and magnetic field. This time all the three are same, right? So only charge of proton is different. mv by qb. Only charge of neutron is different. mv by q alpha b. See, mass into velocity is same this time. Why is it same this time? Because question has mentioned that momentum is same and momentum is mass into velocity. So that's why we are saying this question, this is the same. Fine. Now magnetic field will also get cancelled. So what are we left with? 1 by charge of this. So this becomes 1 by e. This also becomes 1 by e. And this becomes 1 by 2e. So what is the ratio? 1 is to 1 is to half. 0.5 also you can write. Fine. This is the way you have to solve the question. Now the third part is saying same kinetic energy. So now formula of kinetic energy is what? Q square B square R square divided by 2m. So it is saying kinetic energy is same this time. So it is saying you have the same kinetic energy. So if you have the same kinetic energy, what is the radius from here? Let's find out the radius, because ultimate what our question is that we have to find out the radius. So if we use this formula, R is equal to QB by MV. Sorry, I have written it opposite. R is equal to MV by QB. If we use this formula, will we get kinetic energy in any ways from here? We are not getting kinetic energy from here. Otherwise, you have to take half, you have to multiply another velocity. From where will you do? Right, it is just MV by QB here. So this formula, it means it's not valid. If we go by this formula, Q square B square R square by 2m, if we find out the value of R from this formula, at least we'll have kinetic energy in our term. We'll have kinetic energy on one side. So now we could cancel kinetic energy. Otherwise, if you still go by this formula, mass is also different, velocity is also different, charge is also different. Only magnetic field is same. So will you be able to find out the answer? That's why we require proper steps for kinetic energy. That's why we are not going by this formula this time. We have to introduce the term that is same velocity was there in the formula. Velocity was already there, so we could solve it. Same momentum, so in the formula momentum was already there, so we could solve it. Now same kinetic energy is not there in your formula, so you have to build it up. What is the formula of radius from here? See, what is the formula of radius? If you solve it, this becomes 2m kinetic energy by, see, this will be under root and QB, right? Square will get cancelled from the square, and 2m by KE. See, it's like radius will be under root 2m kinetic energy by Q square B square. So under root Q square B square can be written like this. Now at least we have something which we can solve. Look, the masses relation we know. Kinetic energy is already same in this question. Charges relation we already know, and magnetic field is also same. Now at least you can solve this. What is the ratio of proton is to ratio of neutron is to ratio of alpha particle? All right. So under root 2, mass of proton will be mp. Kinetic energy is same. So kinetic energy, charge of proton is E and magnetic field is B, is 2. Now relations for deuteron. For deuteron 2, what is the mass of deuteron? Mass of deuteron is double. So 2 into, this is 2 mp. Kinetic energy will be the same by the charge on deuteron is E, magnetic field B is 2 under root 2. Mass of alpha particle is 4 times. So this becomes 4 mp into kinetic energy divided by charge is also double. Now you just have to find out the ratio of this. See, mp ke eb. This gets cancelled. mp ke eb, mp ke eb. From here, we are just left with root 2. No, root 2 will also get cancelled. Root 2, root 2, root 2. Root 2 will also get cancelled. No. So from here, this entire bracket got cancelled. So 1 is 2. From here, this 2 under root 2 is left. From here, under root 4 is left. So under root, no, this becomes under root 4 by 2. See class, under root 4 by 2, that becomes 2 by 2, which is 1. Is to 1. 1 is to root 2 is to 1. This 2 and this 2 got cancelled. So that became root 2. All right. One more part is left. No, same potential difference. Yes, same potential difference. Now you have to relate potential difference. See, this is a little difficult part. Why is this a little difficult part? Because you do not remember the formula of it. There is a lesson in your class 12th only. Towards the end, you have a lesson, dual nature of matter and radiation. That we'll study later on. But one formula is there where it has a relation that kinetic energy is charged into potential. Because at the end, once the questions come in your exam, they'll not be separate questions, because by that time all the lessons would have been covered. So all the chapters will be mixed. So that's why this formula is derived from your last lesson. So I am telling you the formula because right now you people do not know. But by the end of the session, you should be able to relate all the formula. If a formula is from one chapter, you should be able to write it into another lesson. So kinetic energy is QB. Now, what is the radius? Radius was 2m into kinetic energy. So I will write QB over here into QB. This is the formula that I will use. So radius of proton is to radius of deuteron is to radius of alpha particle. See, 2 mass of proton, charge of proton, potential by charge of proton into magnetic field. Only mass is different. Potential is also same. Charge we know, mass I have written, 2 is a constant, magnetic field is same because all the charges are put in a same magnetic field. This is 2 times the mass of proton, charge is same, potential by electric, this charge is also same, magnetic field. Now for alpha particle, this becomes 4 times the mass of proton, charge is also double, V by charge is double into magnetic field. This root 2 from everywhere will be cancelled, EV will be cancelled. And in the denominator, EB will be cancelled. So what are we left with now? See, from here, nothing is left, 1. From here, EB, MP2, EV, this root 2 is left. From here, this is root 8 by 2. See, this is root 8 by 2. So 2 root 2 by 2, 2 get cancelled. Again, root 2 is left. This is the answer. Tell me, all the 4 parts, or if a different question comes, will you be able to handle? You just have to find out the formula. See, how did we solve all the question? We tried to find that formula that is related to the radius, which can get cancelled. If I just keep on using the formula QB by MV by QB, MV by QB. So how will I relate it with then potential, or how will I relate it with kinetic energy? I have to include kinetic energy in my formula. I have to include velocity in my formula. I have to include potential in my formula. I have to include that quantity in the formula, which can easily get cancelled, because otherwise, how will you calculate the ratio? In your ratio, no variable should be there. MP, so write everything in terms of MP. Note down this question. It's a lengthy question. Wherever you are getting stuck, whichever part you want me to repeat, please let me know, because this is a common question and different particles are given. This time proton, deuteron and alpha particle were given. Any particle can be given to you. So you have to relate it. It can be given that a proton and an electron are only kept, right? So different questions can be there, but see, mostly alpha particle and proton are given together, because everything is related. You are able to easily cancel it. In mass of electron and mass of proton have no relation with each other. So it's difficult. But mass of deuteron, mass of alpha particle, helium, all these are very much related, right? Note it down. Any doubts you have, please get it clarified here only. So these types of questions come from your case 3, when particle is perpendicular to magnetic field. You have questions based on radius, based on time, kinetic energy, frequency and angular frequency can also be asked. So this is an important section. Here you're asking, no, not 4 square MP. See, 4 MP by 2E it was. MP and E got cancelled from here. 4 by 2 is 2. That's what I've written. I've cancelled this. See, this completes your 3 cases. Now, one last case is left. See, 3 angles we have studied, right? First two were 0 degree. Secondly, no, first was 0 degree. Second was 180 degree. Third is 90 degree. Fourth one. See, if the angle is neither 0 nor 180 nor 90 degree, none of these. So now how you have to solve it? See, if the particle is at an angle, and this is not making one such angle, it's at a random angle. It's how will you now solve the questions? Suppose this is a charged particle, fine. This is moving at a random angle with velocity v. This angle can be anything. Now see, if this is making angle theta, then you can resolve the velocities. Along the axis, you will get v cos theta, which is the parallel component to it. Perpendicular to it, you will get the perpendicular component, that is v sin theta, sorry. This is v sin theta. So you have v cos theta, v sin theta. Now see how will be the motion of the particle. There are 2 velocities component now, v parallel and v perpendicular. So parallel does it what? Parallel moves the charged particle in a straight line. Right? The parallel component moves the charged particle in straight line. And perpendicular gives it a upward push. So that makes it a circular path. So forward, then circular. Forward because of parallel, circular because of perpendicular, then parallel because of then straight because of parallel, circular because of perpendicular. So entire motion is like this. Then forward, then curved, then forward, then curved. What is this shape? Can you relate it? This is actually a helical shape. See, like this. This is because of perpendicular, forward push because of parallel, then perpendicular, parallel, like this. This is known as the helical path. So look, V parallel moves the charge in a straight line and V perpendicular moves the particle in a circle. So straight plus curved, straight plus curved, that gives it this is a helical path. This gives it a helical path. Forward straight. Now see radius. Radius is also mv by qb. So here, which velocity will you use? If suppose a question is asked to you, so you will be confused then whether you have to use v perpendicular or v parallel. Always remember, you are getting radius in a circle and circular one is because of perpendicular. So you will use v perpendicular. This is just a slight difference in the formula. Lorentz force, okay, note down this case force. So at least this completes off with all the 4 cases. This comes in your theory. It's a theoretical question. If numericals are asked, that is usually from case. Quickly note it down. Text me done once you have written till here, all of you.
Done.
Fine then. Very few minutes are left, so I don't think so. Lorentz force, the rest of the part will be completed. By next week, we'll try to finish off this lesson because all these portions are very small. The lengthiest was magnetic Lorentz force and ampere circuital law. So these aren't very lengthy. We should be able to complete them by the next week. All right, you people can leave them. Thank you so much, class.
Thank you.